There we go. Yeah, for those of you who don't know me, my name is Nina. I work at CAWR, which is the Center for Agroecology, Water and Resilience, and I'm very pleased to be moderating this session today. So just to somehow clarify and set this in context, the session today is part of our Farming for Climate Justice webinar series. And that webinar series is part of a wider collaboration between CAWR at Coventry University in the UK and the Bioeconomy Research Chair at the University of Cape Town in South Africa. And we have funding from the British Council for this collaboration. And the purpose is to build a network, an interdisciplinary network of early career researchers in South Africa and the UK, both from academia and from civil society, with a focus on the transformation of food and farming systems. And we will support this emerging network, and we will co-produce some transformative research, which will bridge different ways of knowing and which will challenge colonial, extractive ways of doing research. That's our intention. There will be a total of 3 webinars taking place today. Oh, George, is it at all possible to share the screen with those webinars? I thought that could be quite nice. If you can do that from your end, that would be great as a sort of reminder. So yes, there will be a total of 3 webinars, and they take place today and over the next 2 weeks, always on Wednesdays at 3 p.m. GMT +1, which is 3 p.m. UK time and 4 p.m. South Africa time. And the webinars are open to everyone, so not just project participants. So please join us and pass on the word as well. Yeah,
I'm going to share that now. I'm so sorry I was delayed.
No worries.
That's
fine.
Prepared for that.
yeah, no problem. I could have warned you further in advance. It's quite small. George, maybe you can sort of zoom in somehow. That would be great. Perfect.
How's that?
That's perfect. So there are the 3 seminars. I just thought it would be nice to have them kind of come up there as a reminder. Yeah, but also just to kind of step back there for a second, I wanted to clarify that our project starts from a recognition that a transition to agroecological farming systems is necessary, and that is both from a point of view of resilience in the face of climate chaos, but also from a point of view of social and ecological justice. And so we'll be digging into this recognition, into this assumption in different ways and from different angles over the next few weeks. And today's session is on the theme of resilience and adaptation. And we have 2 speakers, Bastien Deppois, a hydrologist and climate scientist at CAWR, who will lay some foundations on agroecological systems in the face of climate disruption from a natural science perspective and with a focus on different timescales. And we also have Gareth Haysom, a human geographer, I think, from the African Center for Cities at the University of Cape Town. And Gareth will focus on urbanization and food and farming systems. And so this week is a more traditional, maybe lecture style format. So we have Bastien and Gareth, who will each talk for about 40 minutes, and then we will open the floor for discussion. So we envisage it like this. You pose your questions in the chat as we go along, whenever they arise, and we will keep an eye on the chat. And once we move into discussion, we will invite some or all of you to ask them out loud later, okay? But keep track of them as we go along in the chat. And so before I hand over to Bastien, I would encourage all of you, yes, all of you, but especially our early career fellows, to hold the idea of unevenness, so of uneven or asymmetric impacts in your mind as you listen to our first 2 speakers. And we would really like to explore diversity, difference, and inequalities as part of this entire series. And so we want to encourage you to start having that kind of lens from the beginning. And I think that's all from me for now. So Bastien, over to you.
Yeah, I'm just gonna share my screen again. So you all can see my screen now. That's fine. Just gonna
We
yeah,
can, we
just
can
gonna
see.
open the chat. So I got some things here. No, not this here, but yeah. So so good afternoon, everyone. So like Nina just said, today Gareth and I will discuss about specifically about climate change and urbanization and its combined effect on agroecological system. I will first talk about climate change and its impact. So after introducing what climate change and what is climate change and climate viability, we will discuss about the biophysical processes through which climate impact agroecological system. And then I will present the different ways through which we currently try to predict climate impact on agroecological system. And finally, I will show some example of climate change prediction and what they are telling us. After this, I will leave you with Gareth for another 30-40 minutes as well. And then we will be back together to open a discussion on the different pathways on adaptation and mitigation. So let's first talk about climate change and climate viability and their impact. So before we go further in detail, we need to know that when we talk about climate, we are talking about long-term variation from change occurring in seasonal properties to change occurring at the scale of centuries. So when we talk if we talk particularly about climate change, we refer to long-term trends in climate average over decades or longer period. But climate also varies at a shorter time scale, and that's called climate viability. So to give you another example of what's climate change, what's climate change and climate viability, if we look at this so if we look at the global temperature over the 20th and 21st century, we note a warming trend between 1970 and now, and this warming trend can actually be interpreted as a signature of climate change, a change in the climate average over a period of several decades. Meanwhile, all the variations that you find modulating this warming from one year to another describe the impact of climate viability. So if you want, all this blue range of symbolize the climate viability, and climate change is basically the trend that is that climate is following. So let's first look specifically at the impact of climate change. So if we look at the change in temperature and precipitation between two periods, so the period 1985 2005 and the period 2080 and 2100. So basically the end of the 21st century compared to the previous previous decade in the current climate. We can actually quantify like the potential future changes. So when we first look at the map related to the change in temperature, the yellow and orange indicate the moderate warming, while like the dark red and purple indicate an extreme warming. When we look at the map related to the change in precipitation, light green means a slightly more precipitation, while like dark blue indicates a lot more precipitation. Similarly, tan and brown indicate a certain level of dryness. So when we look at these two patterns, we can identify different things which are important actually for us. For example, when we first look at the change in temperature, we can see that the warming is actually more important over land than over the ocean. We can also see that the warming is more important inland than over the coastal region. We can see as well that the warming is more important at the pole than in the tropic, and more important at the equator than in the tropic. And we can also see that the warming is actually more important in the Arctic region than on the Antarctic. So the warming is more important in the northern hemisphere than in the southern hemisphere. Then if we compare the trend in warming compared to the trend in precipitation, you can see that warming temperature doesn't always translate to more rainfall or less rainfall in many places of the world. Actually, the relationship between rainfall and temperature change are quite diverse in different regions of the world. So you can see that at the equator, we actually expect wetter climate. But then in all the tropical, subtropical area, we actually usually expect more drier conditions. And we also expect that the higher latitude should receive less precipitation than in the previous climate. And this change in the average climate or in the mean condition also have an impact on the frequency of extreme events. So to illustrate this impact, we look at the statistical distribution of daily temperature. So when we look at this statistical distribution, when we look at the left, that's the probability of cold event. On the right, it's the probability of hot event. And when this curve is actually at the highest, it means it's the most probable, and it's actually in this condition the average. So if we compare the statistical distribution of the previous climates or current climate to the future one, we see that the mean is shifting toward warmer climate. And this means that what we used to consider as a cold weather might no longer be detected in the future climate. And more importantly, what we used to consider as a extremely hot weather in the previous climate will become much more likely in the future climate. And we may even record some days that will be hotter than ever recorded in the past. I will also just talk briefly about climate variability. So this diagram is representing the different time scale at which climate varies. So from change in weather to change in the tectonic cycle, orbital cycle, etc. But more importantly, what's actually important for us over the 20th and 21st century are only these few modes of climate variability here. So which are actually modulating the impact of the human activities and the impact of climate change. And so there are various modes of climate variability. We won't really have time today to go in much detail for all of them. So I was just planning to introduce one of them, which is probably the most famous as well. And I'm pretty sure that most people, for example, in South Africa, have been hearing about this. And so that's El Niño Southern Oscillation, or ENSO. So ENSO is a periodic fluctuation in the sea surface temperature and in the overlying air pressure across the equatorial Pacific Ocean. So basically, every 2 or 6 years, the equatorial Pacific Ocean is becoming warmer. So that would be called an El Niño condition, such as in November. And then it's gonna followed by a period when the Pacific Ocean is gonna be colder for a certain period of time, and this is called a La Niña condition. So from it's an oscillation in change in the sea surface temperature in the Pacific. And this mode of variability will have a strong impact on the atmospheric circulation, especially at the equator. So as you can see here in the normal conditions, so or La Nina condition, when it's cooler over the equatorial Pacific, you've got such a circular atmosphere, cellular atmospheric circulation at the equator, which is called the Walker circulation. And this zonal or Walker circulation is actually determining which region is going to be wetter or drier, over most of the world in the tropical area. But when actually the Pacific becomes warmer for a certain number of years, this circulation will change almost entirely. And so regions that used to be wetter, such as here in Africa, will become drier, and same here for over the maritime continent. And actually, like the impact of El Nino, I need to wait a bit here. I don't know why it's always lagging. So it's gonna come back. Sorry. Yeah. So if we look more specifically at what is the impact of El Nino, you can see that El Nino is actually impacting most of the world. So you see here South Africa becoming drier when during an El Nino condition, West Africa, a large part of Asia having different anomalies, the same for North America, South America. So actually have an impact all over the world, and also means that when it's what we are seeing here is that when it's, for example, warmer here, for 2 or 3 years, it's going to be drier in or wetter in different places of the world. Okay, it's going to be slow here. Why is it so slow? So I've got some problem just changing my slide. Oh, sorry, I need to share my slide again. Yeah, sorry about this. I don't know why I always got this problem on this slide. So that was the point about climate variability. Now we are going to talk a bit more about the biophysical processes that actually are related to make the climate impact the agroecological system. So fundamentally, climate affects plants through photosynthesis. And so the photosynthesis itself needs light for temperature and needs water to actually bring the nutrient that are necessary for the photosynthesis to occur. And it's through the photosynthesis that the plant build up the sugar that they need to grow with. So generally, when it's warmer, you get faster photosynthesis, and that leads to faster plant growth. But when you reach a certain threshold or a tipping point, as climate gets hotter and hotter, the photosynthesis is reduced. So warm extreme temperature, like we get over much of semi-arid and arid Africa, actually lead to reduced photosynthesis. That's, for instance, why there is no plant in the Sahara or in any hot desert of the world. So climate also affects photosynthesis through water stress, and that is in three main ways. The first is through the effect of water shortage on photosynthetic reactions in the leaves themselves. So when there is a shortage of water, the reactions that use water in the leaves are slowed down, and so photosynthesis is slowed down too. The second is through water, is through plants wanting to reduce transpiration. So when they are under stress. So the way they do this is that they close or make the pores on the leaves smaller than they were. So they lose less water through the leaves as transpiration. But at the same time, this means less carbon dioxide can be brought in from the atmosphere into the leaf, and this limits the photosynthesis activity. Then the final way that water affects plant growth is through water logging. So if you have too much water in the soil, that actually reduces the effectiveness of the roots and all the microorganisms that are working with the roots to bring nutrients in the plant system. Therefore, the plant's growth is slowing down as well. And more importantly, the impact of heat stress on photosynthesis becomes much worse when plants are under water stress. And so the combined impact of temperature and rainfall will also have different effects during the plant growth cycle. The climate also affects agroecological system in different ways, maybe more mechanical ways. So during the seeding stage, for instance, if you have a heavy rainfall event, you can have all the seedlings washed out of the soil, and you lose your whole crop. The rain, hail, and sunburn can also seriously damage your crop, as well as the quality of the fruits during the ripening stage. And in more extreme cases, but it is particularly relevant for our colleague in Cape Town at the moment as well, wildfire are causing serious damage to the environment, and actually wildfire are more likely to occur in a dry and hot weather. Then we need also to note that climate also affects pests. Many of the biggest pest outbreak can cause that cause with the spread crop damage were triggered by climate. And even though this might sound a bit strange in some places of the world, such as Africa, cold spells can produce damage to the crop as well. Also, so far I mainly talk about crops, but changes in climate also impact livestock. So, for instance, if it's too hot, they will be looking for shade and spending less time foraging and eating, leading to poor health and weight loss. And obviously, water stress, especially drought, have critical impact on livestock. Like the animal can just lead to the death of the animal as well. Therefore, as rainfall and temperature vary from one year to another, crop yields also show a certain range of interannual variability. So here we look at the coefficient of variation of yield for maize, rice, wheat, and soybean. And so you can see that there is quite a strong variability, particularly in maize over South Africa, Southern Africa, and East Africa, but also for other crops in other places of the world, and also for maize in other places of the world. But more importantly, if we then try to examine how much of this variability can actually be explained by climate variations, so variations in temperature, precipitation, and or a combination of both, we found that actually more than a third of the crop yields variability can be explained by climate. And if you look specifically at these different plots, you can see that here for maize over East and Southern Africa, sometimes we can explain up to 75% of the variance, which is like 3/4 of the variability. And that's also true for wheat, particularly in Europe as well, or rice in Asia. So this means that we actually can develop some kind of predicting system to have some scenario of future impact of climate on agroecological system. And to do this, we need to do two things. We need to take the output of a climate model, either global or regional. So that's just a difference of spatial domain and also in resolution. And eventually, we need to apply some bias correction if the model wasn't originally able to produce a realistic variability in precipitation or temperature. And then we need to input this data in a sector-specific impact model. So, for instance, in the context of agriculture or agricultural production, we need to use a crop model or an empirical equation between historical crop yield and climate variation. And we can actually use a similar system to predict the species distribution or water resources, which would just be using a different impact model. And so hopefully for us, we actually can predict climate at different time scale, and this will actually provide different impact scenario as well at different scale as well. So as illustrated on this diagram, the weather prediction are limited to about 2 weeks, usually, because the atmosphere is following chaotic behavior, which means that anything occurring in the atmosphere at day 0 might be totally different a few days later and totally uncorrelated, so totally unpredictable. However, there are more slowly varying components whose behavior is more predictable in the climate system. And their interaction with the atmosphere allows us to increase our forecasting timescale. So we were talking, for instance, about land surface processes. Just an example, if the soil is covered of snow, this means that the atmosphere is more likely to stay colder for a longer period. So we can use this to improve the lead time of our forecast. But and at longer time scale, such as seasonal or internal time scale, we mostly use ocean surface temperature. So, for example, the condition occurring over the Pacific Ocean, like we've seen before, and or the occurrence of ENSO event. And we use the relationship between ENSO and the precipitation and temperature throughout the world to actually fit an impact model. So this kind of forecast, like seasonal or internal forecast, are actually what's most commonly used by the stakeholder and maybe also by practitioners, but we've got a bit less evidence of this because it gives specific information for the coming 3 months or the coming year. So that's actually more useful and more used by end user. And at even longer time scale, in addition of being able to use a natural mode of climate variability such as ENSO, we also can use some scenarios of greenhouse gases concentration in the atmosphere, because we know how the temperature will change if we've got a certain concentration of greenhouse gases in the atmosphere. We develop this kind of scenario to predict what's going to be the temperature in the future and what will be the impact for the precipitation. And so this type of prediction of prediction are called climate change scenarios. And they actually provide information for the coming decades or 100 years. Unfortunately, they are also very rarely used by the practitioners or stakeholders now, because they don't really provide specific information for the next season or next year, but provide long-term information, which are actually more useful for long-term investment or long-term decision making. So just to give you some examples, so here is an example of seasonal forecast. So this forecast was made in September 2020, when a La Niña condition was actually developing over the Pacific Ocean. So because a La Niña condition, because it was cooler over the Pacific Ocean, we knew that for a couple of months or a year, some regions were going to be more likely to be dry or cool over the world. So for example, in this forecast, which was made in September, we predicted what was going to be the condition in October, November, December 2020. So on the following season. So you could see that using this this model, we could predict that East Africa will be drier, or Southern Africa will be a bit wetter over the coming 3 months, and we could do similar prediction for North America and South America, or everywhere in the world. So this kind of forecasts are all available on the website of Columbia University. So you can use this link to have a look at them, and you can even create your own forecast using their portal. So obviously, when you know what the relationship between rainfall, temperature, and the crop, you can actually use this information from the seasonal forecast. So from the seasonal forecast we got for precipitation and temperature, use this forecast to actually predict what will be the impact on the crop yield. So this is an example of seasonal forecast specifically for soybean over the world. So here I just show how good are the prediction in different places of the world. So everywhere where you've got color, we could actually predict more than half of the variability of the crop yield over several decades. So you can see here, you can see a good scale in Argentina, in Brazil, North America, a large part of Asia, South Africa, Nigeria. And then if you want to compare, so here in the result, so the black line here is what the historical yield for soybean, and the blue line is what the result of the simulation for each year. And so you can see that it's not perfect, but we can roughly produce quite well the variability of the crop yield over time. So now I'm going to talk a bit more about the climate change scenario, so much longer term scenario. So as we've seen before, over the 21st century, climate is getting warmer, and the rainfall distribution is going to change in many places of the world. So here we are looking at a summary of projected change in crop yields due to climate change over the 21st century. Mostly, this graph includes data on wheat, maize, rice, and soy, and the figure combines data throughout the world from different greenhouse gases emission scenarios. And but what we note from this figure is that without adaptation, climate change is projected to negatively impact crop production at the global scale. And if we want to be more specific, if we just look at the last 2 decades of this projection here, we can see that actually about 80% of all the simulation we produce are actually predicting.
You present yourself as proof.
Right. So 80% of the scenario show a decrease in yield over the 21st century. And actually half of this scenario suggests that this decrease will be approximating about 50% of the yield by the end of the 21st century. Of course, so these future changes in crop production are not equal throughout the world. So if we first look at the top panel here, which is showing the average changes by 2080 for maize, wheat, and soybean, we can see that yield losses mostly occur in tropical and subtropical region. So mostly in hot region of the world. Well, like if we look at the northern countries or colder region, for some region we actually may expect an increase in the crop yields as a result of the warming temperature. So this difference between the north and the south actually mainly because, like we've seen before, when the warming temperature reach a certain threshold, the warmer temperature actually lead to reduced photosynthesis. So, as illustrated here in the bottom panel, you can see that this is mainly linked to CO2 fertilization. So this means that in colder regions, so here, the temperature won't be reaching a tipping point, so the plant will still be fertilizing the CO2, and so we will have an increase in the crop yield. While in the southern region or outer region, the temperature will be reaching a tipping point, so the photosynthesis will actually the photosynthesis activity should actually decrease. And in these studies, I was also adding another level of complexity for this scenario, because most of the existing scenario before 2014 did not account for the occurrence of extremely hot days at anthesis. So when anthesis is when the crop is flowering, and they actually found that without any extremely hot days at the flowering stage of the crop, we will actually have an increase in yield everywhere, which also means that if we actually do have extremely hot days occurring during the flowering stage over the 21st century, we may have a reduce in crop yield everywhere in the world, including the northern region. So this means that actually even the first scenario that we've got, which may already look quite pessimistic for most of the world, may actually be even more pessimistic than we expected. So I'm gonna now talk a bit more about the impact, the added value of or the benefit of adaptation. So relatively recently, a study compiled a substantial amount of data on agricultural practices in various regions of the world. In particular, we recorded the different adaptation practices, such as the use of irrigation, improved irrigation, the use of fertilizer, or the changes in planting date, etc. And then they estimated how the regions that did or did not adapted their practice have been impacted by the warming temperature over the last decade. So using this study, we could actually find that in some region, the actual impact of climate change, so the impact of the warming over the last decade, could have been substantially mitigated. So that's particularly true for the rice in tropical region. So if you look at here, the blue curve is the result from a region where the practice, like the farmer adopted their practice, and the orange curve is the result of the location where the farmers did not adapt their practice. So you can see that with adaptation, you've got an increase in yields and a decrease in yields if you did not adapt your practice. And we got similar result for wheat in temperate region with an increase in wheat yields with adaptation and a decrease without adaptation. In contrast, if you look at the maize and wheat for the tropical region, there is currently very little evidence for a potential to avoid yield loss in maize and wheat. But specifically for wheat, the author also put their result into caution because a number of studies that they were actually analyzing over here, and same for the rice interpretation, is actually quite low. So they might need actually more data to have more robust result too. And even if I'm not gonna expand much on this, I just wanted to talk about another pathway toward adaptation, which could be through transformational practice. So for instance, using climate information from climate models, we can first identify which area will be at risk and when the risk will be highest over the 21st century. So for instance, on this figure, when we examine, we can examine where and when the climate condition will become unsuitable for certain crop. So areas that are in gray here are adaptation where no adaptation should be needed. An area that you find in color indicate the region where adaptation will be needed and at what period of the 21st century the climate will become unsuitable for all the different crops. So we can see that about 60% of the area cultivating bean will see their climate become unsuitable over the course of the 21st century in Africa. And so this translates into 1.85 hectares of farmland, which is actually currently producing more than 40% of all the bean for sub-Saharan Africa. So actually quite a substantial loss. Then the same study also suggested that key banana growing region in West Africa and maize growing region in Southern Africa will also see their climate become unsuitable over the 21st century. On the contrary, this study shows that root crops like yam and cassava, or the drought-resistant cereal like the pearl millet, finger millet, and sorghum, are less affected by climate change. So you can see that on this map that everything remains gray, so there is no much risk over the continent. While like for the bean, banana, and maize, at some point we will have some problem. So using this information, we also can identify a region where no adaptation is required. So basically, region in gray here, and also suggest some alternative practices in region where adaptation is needed. So we can highlight which crop, for example, here the pearl millet, will be more suitable by the end of the 21st century, and also how many crops in this area. It means that so when it's dark gray, it means that actually none of the crops that were previously analyzed will benefit from a suitable climate over the 21st century. So which means that in this area, we may have to look for other adaptation pathway. Yeah, so Nina just told me I just got a couple of minutes, which is fine because I'm done. And so we can discuss a bit more about this kind of about this adaptation and other ways of adaptation in the final part of the lecture. And I'm gonna now let you with Gareth for the next 30-40 minutes. Thank you. Need to stop sharing as well.
Thank you so much, Bastien. So that was really interesting to me, completely different kind of angle of things than I usually engage with. So thanks for that, Bastien. I hope that many of you got something out of this and found some interesting points of inquiry. And Gareth, why don't you move on, starting to talk about urbanization?
Thank you so much, Linda, and thank you, Bastien. I'm going to share my screen. And apologies, go to the beginning. There you go. So yeah, so I'm gonna, my talk will be very different, and I would imagine perhaps might be something a little bit different to what has normally been presented and that might be expected in this, and yeah, just going to really speak to the questions of urbanization and what this might mean for food system change, and specifically looking more at the food system, not necessarily only farming systems, but certainly taking cognizance of that, but also in a really trying to say what is happening across South Africa and Africa around urbanization, and how does this intersect, and are there opportunities for agroecology to start playing a far greater role in the practices necessary to rupture the current dominant food system that we have, and given how I argue how urbanized how urban our food system actually is.
Gareth, can I just point out that I don't know if this is on purpose, but we can see your presenter's view rather than your slides as full on the screen.
Let me then disconnect that, and that might change. Thank you. That wasn't intentional. So let me exit part. I'm going to share again. Sorry, thank you for interrupting and saying that. Let me escape from here and stop sharing it, and I'll start to share again. Hopefully that will work. Great. Is that better now?
That's perfect. Thank you so much, Gareth.
Great. So yeah, so for those of you that know, and if Nazir and others in the room, this is just an interesting picture that speaks to some of the sort of structuring of the food system. And this is the Philippi horticultural area in Cape Town. Really background, I'm just going to give some background to the climate impacts on food and urban systems, just very brief over. Most of you know these figures already, so it's just really to run through that, to talk a bit about urbanization. And then I'm going to delve into the sort of South African food system in a more political economy, critical way to try and understand that. And I want to sort of speak to the role of food access in the system and what that might mean. And really, I suppose, to sort of preempt what I want to discuss, building on this notion of how agroecology and the discussions around that, around sort of really reclaiming the means of production and agency in the production focus, can we also start thinking about the urban areas as sites where we can start reclaiming the means of access and reclaiming agency in these spaces as well. I'll then speak a little bit more to sort of emerging food system actions, and I want to take a critical view of that in the context of where we sit in South Africa and the South, and then try and sort of link in perhaps a somewhat unsophisticated way some of the principles of agroecology and ask how do these land in the city and the urban space. But before I start, I do just want to give recognition to my own history and my own journey into this. And I think it's important, given that I'm going to be talking about the history of the South African system. But I grew up sort of my family sort of followed John Seymour's Complete Guide to Self-Sufficiency and realized how tough it was. But later in life, I was lucky enough to engage in a partnership and a long-term friendship with partners in Damitra in India, a group of farmers who were battling with the sort of remnants of the Green Revolution and trying to recalibrate the entire farming systems. And so being able to visit and observe what they were going through, and my visits there and the period there prompted really deep reflection, because one of the things that I hadn't expected but noticed there was how connected these groupings were and these actions that were linked to the urban space, to the retail system, to how the entire food system was being considered. So whilst There's fantastic work happening around production, diversifying the food system, seed saving, multiple different forms of agency and action, and different knowledge generation processes. There was also this interesting connection that I would argue, and some might disagree, and we can talk through this, that I think this is often absent in some of the South African agroecological discussions that play out, but we can get into that later. So many of you know the Eat Lancet Commission came out and sort of really amplified the impact of the food system on the climate system and planetary boundaries and how it was driving this proverbial race to the bottom. This is not new. Way back in the mid-2000s, the IAASTD, the sort of Agriculture at the Crossroads report, made these similar points and demonstrated the politics in the global food system at the time in terms of who was willing to ratify that report. But then more recently, the IPES reports and all of those have also been really insightful in presenting this. So that's there, it's known, I won't go into it, but just by means of reference for everyone else. But equally, cities are being seen as these sites of massive consumption. And between the food system and the urban system, these are arguably two of the biggest drivers of sort of climate risks that we face, pushing the planetary boundaries beyond anywhere that we know, and how these transformations in urban systems are going to be driving a whole lot of these processes. But equally, as cities grow and expand, they eat into land that is very important sinks to help with this climate adaptation. So trying to think how the food system and the urban system combine, for me, is also something that I feel is an important question. And I've deliberately used this image because it does also speak to how much of the urban discussion is being oriented towards this technological fetishism of smart cities, material flows analysis and things like that. And I think this misses a lot of the really interesting things that are going on in these cities. While that might be great aspirations, these are being captured by the likes of the World Economic Forum, around the, the AI and around smart cities, and there's very little critique in the urban sector around this. And again, so this need for far greater critique of the role of cities and how these might change and the processes necessary to facilitate that change. And so this is the everyday of most South Africans, not this city that is represented down here. And for me, this is the South Africans who are already experiencing the kind of negative kind of consequences of climate variability. This here is the wetland in the Cape South, wetland in Masiphumelele settlement, just sort of in the South Cape, Western Cape or Cape Town South Peninsula. And for me, the question is, what type of food systems are serving these communities, and what role can agroecology play in rupturing the seemingly intractable issues that we have around that these communities face? I don't have all the answers, and this is the provocation that I wish to present here. And I really want to say that I think for me, the struggle needs to be the struggle around agroecology and the ways in which we can try to think through food system transformation, and the role of the food system in climate has to also land in these particular places. Because I think how these two sites support one another become important. And so this notion of controlling the means of production, but also controlling the means of access, and also finding ways to control how food and space and place connect. So those of you who might have had any interest in urban food might have read Caroline Steele's book. And she says, in order to understand cities properly, we need to understand them through food. And it goes without saying in our work, but we use food as this lens. And so looking at the food system, this is a collection of images from a small town called Worcester in South Africa, embedded within an agricultural economy with a deeply problematic history of the DOP system, still high levels of fetal alcohol syndrome in this town. 27%, a report came out this week, of children are still stunted. So here we have a food system, but it's not a system that's serving the needs of the population, be it urban or rural. These images, bar the one with the goats, could probably be images of a food system in any South African city. And so for me, I think the question is what ruptures are necessary and how can these take place? How can these food systems that are creating these significant negative externalities, how can they be changed? And what role does agroecology play in trying to shift some of those questions? So I think there are three kind of questions that I want to pose around this. First, I think we need to understand how the systems are structured and how the structuring has enabled a particular system over time. And what is that historical trajectory? Second, given that South Africa is, almost 2/3 urban, we need to pay attention to the urban food system and how that is changing other systems. And thirdly, I think, given that the urban demographic, we need to understand how this food and urban system comes together. I do want to be clear here, while I'm speaking about cities, this is not to say that the rural is not important or that cities are more important. This is just to say that I think one of my critiques and one of the challenges I sit with, and I sit with this disquiet, is much of the agroecology movement, and many of you in the room might disagree, does predominantly focus on the rural area, and there is even a potentially negative view of cities and the role of the food system. And I do think, can we lift the gaze to see this as being about a broader system transformation process? And in doing that, how do we start to understand cities and the role that they have in the food system, but particularly the negative kind of impacts that they have in terms of climate, and how can the most vulnerable in these cities effectively kind of develop resilience and adaptation strategies, not just to climate change, but also to the implications of this wider and deeply unjust system. So when I speak of the unjust system, this is really the system that is evident. And I think it's important for me to start to say, why do we have the system and how has the system come about? But also, when you see images of this system, and when I present this to city officials and others, the default is to blame local communities in place for making poor choices and determining that this is what they buy, they being in inverted commas, and laying this extensive blame on people for, one, being ignorant, two, being lazy, and three, aspiring for a diet that is a break from culture and desire. And for me, these assumptions are embedded even in policy. The Western Cape District Health Plan lists non-communicable diseases as chronic diseases of lifestyle. Now, this is not a lifestyle choice. This is that people go and purchase from stores who sell these kind of products and will choose these products, as I'll show later, because of real issues in place and real tensions that exist in the locations in which they're embedded. And so these then need to start asking these questions around, how does this food system, how is it a manifestation of the broader lived urban system? But I'll leave that question there, and I just want to go into some discussion around urbanization. And I think for me, why this urban question is such a critically important question, and why the southern view of this is so important. And this is a deeply oversimplified view of the urbanization process, but really the highlights from this is just to say that over a period of 200 years, from 1750 to 1950, the world grew to being predominantly, well, to being 52% urban, or the northern regions, the northern hemisphere grew to be more than 50% urban. That meant a change in population, where the urban population in 1950 was just under 500 million people. In the period between 1950 and 2030, the South is going to absorb another almost 4 billion people to grow to be about 56% urban. So in this very short period of 80 years, this second urbanization process will have to manage and achieve basic needs, and food is certainly one of those basic needs. The rate is unprecedented. The economic foundations, as we can see at this point in time, are already failing. And how do we then do that in a way that is carbon neutral, that doesn't generate significant externalities around and push the planetary boundaries? And these are the questions that I think, and this is for me why I think cities are important sites of study and important sites of struggle. But also, when I speak of cities, just to be very clear, and this is just, I'm not we often have these imaginations of the sort of chaos of Cairo's streets, or the sort of the ungovernability of Lagos, and we think of these large primary cities. But Africa's primary urban growth is not going to happen in these primary cities. Yes, they are going to continue to grow, but it's the secondary cities, for want of a better description, the cities of under 1 million people, that are going to absorb the majority of the urban population. So in 2015, the number of urban Africans residing in cities of 1 million or less totaled nearly 320 million. But those in the larger cities were only 175 million. These secondary cities have very different governance capacities. They have very different relationships with various different systems, and the food system is one of them. But for me, the most important factor around all of this is that whilst this growth is going to be happening and we're going to try and meet that 80-year cycle of growth, the infrastructure and the systems, both governance and physical, that get put in place in the next 20 to 30 years, I would argue, is going to determine Africa's development trajectory and South Africa's development trajectory for the next 100 years. We are going to lock in a very particular system, and this raises the stakes significantly from both a climatic point of view, but also a social and economic justice point of view. And for me, these are the really interesting, well, really important challenges and questions to ask, is how these then intersect with the food system issues, and others are equally challenging. So just, I lifted this quickly and inserted it in here. If one might go back and think of Rutger's model that Bastien presented around those various different growth patterns and where most of the growth was going to take place. And I was struck, this is where most of the urban growth is going to take place. And this was where some of the greatest kind of challenges for adaptation and climate responses sat in Bastien's presentation. But we can go into that in greater detail. I just dropped that in there, so perhaps a bit risky, but just to make that point and show that where Africa is growing is certainly there. And some of you might have seen some of the challenges in South Africa as well. Many of you might know this already, but I think I always find it useful just to reiterate this point and to remember the food regime in which we're sitting. So drawing on Harriet Friedman and Philip McMichael's much earlier work on food regimes, and how the first food regime was really based on empire and the extractive model and allowed that 200-year development trajectory. The second food regime really came about where the state started to intervene and sort of became the organizing factor and really saw the modernization, in inverted commas, of agriculture. And now that shift that then took place in the sort of mid to late 1970s into the third food regime, where it's now dominated by the market. And this is by no means statistically relevant or valid in that, but I find it very interesting when you overlay the global urbanization trends over this process and reflect on how these two come together. And so what does this market-dominated food regime and the high levels of urbanization mean in the context of South Africa? Here I am using food security as a way to describe this, and I'm deeply mindful, and I certainly appreciate the critique of the use of the term food security, making reference particularly to Eric Holt-Hemides and Annie Shattuck's critique of that. So I use it really just to make the point and to show how inequalities are manifest in the food system, and how, and this is some studies that I did in Cape Town, how almost 91% of the lowest income tercile are deemed to be food insecure, certainly not having enough food, not necessarily suffering hunger, but food insecure. But how this continues right up into the third income quintile. And when Corona hit and the virus hit and lockdowns hit, most of that first, second, and third quintiles fell very fast and very rapidly into hunger. When we look at HDDS, the Household Dietary Diversity Score, where a figure of 6 or less is an indicator of potential for undernutrition, you also see the kind of precipice, the precarity of right up potentially even into the fourth income quintile. And then the months of adequate household food provisioning is the last bar, and see how the poorest groups are really experiencing 5 to sometimes sort of 2 and 3 months where they are concerned that they're going to have enough food. And so this is by clearly saying that the market system isn't providing food for everyone. This reflects again in sort of how diet changes across income. And again, I won't go into this too much detail, but if you look at the ability for protein, for other essential nutrients, one starts to see how the red line being the poorest income grouping in the tertiles here, how significantly different their diets are to the rest. So to step back and take a view, and here I use Stuart Brand's just to help make this point, the 6 PACE layer levels and how change happens at these different levels and at these different rates, from fashion to commerce to infrastructure to governance, culture, and right down to nature. So nature will take eons to change, culture generations, governance perhaps even longer, and infrastructure. So how change takes place. And for me, I want to just use this as a back end to have a slightly longer conversation around the South African food system and how it has evolved. And I would like to try and use this to make a point that South Africa, and here Colin Bundy's work around the sort of pre-1860s role of agriculture around a number of very diverse crops, from millets to sorghums to various different other crops, were being farmed by a productive farming group. And there are contestations of Bundy's work, but just to use that here also just to make the point. 2 ruptures happened, the discovery of diamonds and the discovery of gold. And what started to happen is the South African system and the South African economy started to restructure fundamentally. What was needed was labor, and there needed to be a way to control that labor. And there was experiences of importing labor from elsewhere, such as the indentured labor that came from the Indian subcontinent, but that was never seen as ideal. And then the sort of powers that be and the colonial elites then sought to find different ways to adapt that. So we saw the introduction in 1894 of the Glen Grey Act, which was the first form of dispossession, often not discussed, but it was a precursor to the 1913 Native Land Act. What this meant was that no African or person of color was enabled to own land, and was effectively started this dispossession of the land process. And also not able to produce, heavy taxes were imposed on any food that was governed, and really this was a drive to drive Black Africans into labor on the mines. We saw at the same time none other than the Prime Minister of the Cape Colony, Cecil John Rhodes, who then started investing in rail and other networks and importing food through this establishment of new infrastructures, and importing this food from other colonies such as Canada and elsewhere. What this then meant was a move to cities. And this move to cities started to take place, but importantly also, the food system that started to emerge was no longer that traditional sort of agrarian system that was there. We saw this initial start of a system and a food system being designed to service an urban labor force. And laws, taxes, and other things enacted, the Union of South Africa, the 1913 Native Land Act, and this kind of quartering and this exclusion from the land. And again, the primary purpose and what was necessary in this pursuit of having labor working in the mines were that they were living on the periphery of cities, and this labor needed to be kept passive. And as Bob Marley or others have said, an hungry man or person is a hungry person, or man is an angry person. The need to keep passivity. So these workers were then fed with these cheap staples, and that feeding of cheap staples was designed to ensure that the powers that were extracting the maximum value and the elites could then pay the minimum wages and keep people fed, but not necessarily well. You didn't need anyone to live beyond the age of 30 or 35 because they were no longer productive in the mine. So the brutality of this thinking and the challenge that this brought, this speaks for itself. Further dispossession, further moves to urban, but again, the system that is evolving is always an urban system, right back from these early days. The National Party comes to power, we start to see a new farming elite being formed, a group of white farmers then being placed on the land with significant support for them. The introduction of high external input agriculture starts with fertilizers. We then start to see infrastructure being developed, significant state-led inputs into that. We start to see the evolution of monocrops and hybrid seeds starting to take place. And as this evolves, the amount of farmers reduce and we start to see consolidation. Laws and a set of policies, both locally and internationally, start to be enacted to start to drive this process. And then we start to see other processes starting to take place, such as the supermarket revolution, and again, further removal from the land, etc., into these urban areas. So the point of this somewhat long and drawn out slide is to argue that we start to see a food system that is both an urban system, but equally deeply unequal, and it's certainly not a health-giving system. And just to mention, there's a whole set of literature to support some of this work, and this is evolving work to try and speak to it. But the point I want to really make with this rather complex slide is that South Africa's food system has effectively been an urban system for a very long time. And that then sits within these structures that we face. And so when we understand food and look at it in different ways, food is really a key driver of so many other externalities. And Wayne Roberts, the late Wayne Roberts, who spoke to this. And so that image that I showed of the store with all the sort of coup and processed food, the choices to buy that are being made because of these challenges, because infrastructure is so underprovided, because of long transport routes, because of the spatialized segregation that takes place, because of the daily struggles that so many South Africans face in just their everyday, let alone accessing food. And so the informal economy becomes particularly important. And here, just to show how across the income terciles, different groups are then using the various different retail options in different ways. Everyone uses a supermarket, but the frequency of use of the poorest groups, of the spazas, the local stores, are significantly different to the higher income groups. And so these are the forms of resilience. This is how the poor are using these various different options in the food system to drive and to build resilience and to give themselves options. These are food systems that, if able to kind of move in different ways, start to show great diversity and start to really enable access to food. And some of them not necessarily always the best, but certainly there. But as Jennifer Clapp has argued, we need to start, city or governments need to start building different infrastructures for more diverse and local production. And I want to ask the question, and I have asked this of Jennifer Clapp directly, you know, given that history of the South African food system, is the government going to do this? Is the private sector going to start enable this process? Are we not locked into this other trajectory? And while IPAS won't call for food system transformation, the question is, what is that system transformation going to look like? In the North, there are a number of groupings and a number of ideas and processes that are trying to challenge us. Gail Feenstra's work, going right back to Helena Norberg-Hodge's work on localism, the work around food deserts and how that starts to understand things, the real kind of role of urban agriculture and others, food policy councils, city region food systems, questions around the nutrition transition, and questions around sort of food sensitive urban design and planning. But really all of these, in my view, are northern views, and how they land and how they touch in the southern space is yet to be understood. And for me, the challenge in many ways is that these systems don't get into this governance and culture system. They don't enable the ruptures that are necessary in these processes. They're very useful and they can certainly build over time. But for me, what is necessary is something that can get right down into this culture, shift this notion of what is my diet. My work in Zambia, when we interviewed people, someone said, if I had nshima, I've eaten. So if I've had that maize, that single staple, I've eaten. That is the sense of a meal. And that's not the meal that existed before. And that's that kind of normalization of what a meal might be, I think needs change. And I would like to ask that agroecology has the tools to start to unlock these deeper processes that are embedded within and that enable longer system change. Very briefly, just to kind of show how this might play out in certain ways. This is the hammer mill, Shigayo, in Epworth, and Epworth is a particularly interesting site because it's not governed by the Harare municipality, it's governed elsewhere. And so these processes can potentially allow some really interesting things to emerge if one looks at this a little bit different. what happens here is, because of the Zimbabwean land reform, many small-scale farmers who are producing are now wanting to sell their produce. And when that produce comes through, they are reluctant to sell it into the maize board for various reasons, whether they'll get paid is one of them, but also how that system works. And so interestingly, in Epworth, these hammer mills have all been established. Colleagues of mine, Percy Toriro, looked and said there were 4 hammer mills that were supposedly there authorized. He found 167 of these. So the farmers are connecting into these hammer mills. There is this relationship taking place. The food is entering into this urban system. There is this sort of symbiotic relationship between them. And as they move into these areas, they are also fundamentally changing both the sort of logistics systems, the distribution systems, but also changing sort of how food is prepared and creating a variety of different processes that enable that. So if anyone goes to Harare or anywhere around Zimbabwe, certainly everywhere you go, you will see Maputi. And so this site of struggle of the informal economy, this is where the vendors and the networks are collecting, are really driving processes. And for me, how can agroecology serve these vendors equally as they do the farmers? How can they see them as being complete actors in this kind of agroecological change that needs to take place? The informal sector for me is this key site of struggle, and actions to control access are as important in my view as other actions. But as Samora Michel, aluta continua, they are deeply subject to kind of vicious and brutal police responses. In speaking to the informal economy, I just also want to kind of recognize that it's not, you know, Adanya Roy and Wati Chen have all said, you know, we need to be careful of over-valorizing it, romanticizing it. It is also unequal. There is disproportionate benefit. Women often don't achieve the greatest benefit and are the hardest, have to work the hardest and struggle in the greatest way. But having said that, just to really try and say, you know, can these ideas around the agroecology principles, can they change? And I've just highlighted some of them. And I think, you know, on the creation of knowledge, co-creation, I think they all span both indigenous and traditional knowledge, but the knowledge that enables us to hack the urban system is also important. How can land, and so these align with one another in many ways. And so as a provocation, I'd like to end by saying, in my view, is that we need to ask if the current urban food movements are able to create the change. Are they the seeds of change? And I would say that agroecology presents a powerful and far more robust kind of way to challenge the hegemony of the current system. And can urban food system change be better driven by applying the concepts and principles of agroecology to the urban challenge? And for me, agroecology is essential to unlock the sort of 150 years of slow violence that has been enacted on most and the most vulnerable in this society. And how do we sort of use a way to disrupt that? And so whilst I haven't necessarily spoken directly to climate and resilience, I think the system that we have constantly is placing the vulnerable communities and the poor at great risk. And I think there's a real need to use and think of agroecology as a way to rupture that system and to create a different kind of food future, particularly when it's done and viewed through cities, given South Africa's demographic profile. So I'll leave it there and say thank you.
Thank you so much, Gareth. That was a fascinating presentation, and I think really sits really interestingly together with the first one. You know, I have many questions around how the sort of historical perspective you outlined, how that of course, you know, goes hand in hand with some of these climate impacts that that we're seeing across the world, and like, you know, how these things are entangled in both directions. So I'm going to basically open up the floor, and I think, George, are you going to lead us on that? How you have collected some questions? Are you going to call up some people? I think we're going to try and facilitate a bit of a discussion now amongst everybody.
Thanks, Lena. There have been some really interesting questions in the chat. So I'm just going to invite different questioners to turn on their cameras and have an opportunity to quickly introduce themselves and say who you are and where you're speaking from, and then concisely, if possible, pose your question to either Gareth or Bastien. So on that note, I think I'd like to kind of take us back to the issue of adaptation, because there were some questions on adaptation. We had a question from Chloe on adaptation and safeguarding yields. Chloe, would you like to come on screen and ask a question?
Hi, yeah, I was just, Bastien was talking about the difference between the systems that didn't adapt and the ones that did. And there was obviously the benefit for yields. So I was just wondering if the paper had any specific examples of what those adaptations were.
Yeah, so in the paper they just collected all the data about different practices of adaptation. So they collected so when in this paper when they talk about adaptation, it includes if they were using fertilizer, new fertilizer, if they were using irrigation or not using irrigation, if they improve their irrigation system, if they change the date they were planting or things like this. Doesn't also include using other crop, because it's was like information on specific to the different crop. So no, so yeah, they don't really, just like many information about different adaptation practices to collect a large amount of data about on the farm that were like actually adopted their practice and farms that did not, and see how their productions evolved according to the warming of the last 20-30 years. But yeah, it's no, they don't give specific information on specific practice, which I think will probably be also useful. But if they were trying to do this, I think they will also have much less study to compare. So I'm not sure the result would be very robust if they were trying to do it.
That makes sense.
Thank you. Thanks, Bastien, and thanks, Chloe, for that question. And perhaps I'm going to go over to Jane, who has a more political economy or political ecology even question related to who takes responsibility for adaptations, for these adaptations. Jane, do you want to ask your question of, I think this one really for Gareth?
Yeah, I mean, I think it is a question just for all of us to, I suppose, for all of us to hold around if we're talking about climate justice. And what I was struck by Bastien's presentation and then Gareth's is that we were hearing about the almost more than human world and the difficulty of the more than human world to actually connect with the human world because of climate change. Almost, you know, to be able to feed us, there's that disruption. So, I mean, I suppose I keep quite asking myself, we're getting all this clarity about the impacts, and yet how do we generate a solidarity around how we take responsibility for these impacts? And I suppose the reason why this question is so huge in my mind is because of the way we have seen a global response to the COVID-19 virus. So that is the question that I'm holding is at a global scale, it seems like we're on our own. So then if we're talking about adaptation in terms of food systems, and I really like the way we're talking about food systems rather than just food production. You know, what are our options, and who takes responsibility for this, and how do we work in solidarity to ensure that? I'm not expecting an answer. I'm just saying that that's the question that's in my mind at the moment.
Can I maybe just, I mean, Jane, I do think for me, one of the questions and my big anxiety and what prompted this kind of reflective work and trying to understand this was having been very active in trying to find solutions to the 2008 food crisis as it hit in South Africa. And really, I mean, I was there as someone working around and teaching students in agroecology, and I was part of this group that for me was the first time I'd been invited to any of these cycles. It's quite strange, you know, with agricultural economists, but a lot of deep system thinkers trying to really try and find ways around this and think very differently around it. And I was deeply enthused by what started to emerge as potential pathways going forward. And then the crisis stopped and everything went back to business as usual. And so whilst I'm not answering your question, I think I'm sort of layering it with another point of how does this moment precipitate us to really think more deeply about the solidarity that you mentioned, and how do we maintain this process and this recognition of essential change and how that change is so important, and how, you know, Leonie Joubert and others speak directly around the kind of climate related situation as if it's going to be exactly as we're facing now with the pandemic. And so how do we see these as combined, interconnected, and how do we start to build these solidarity networks? And for me, the point is just really say, we need to include cities in those conversations and, you know, in that solidarity grouping. But yeah, but that's just a short answer to that.
Bastien, I think you had a response that you wanted to make to that particular question as well.
Yeah, I mean, it's joining a bit what guys say, but I mean, on the, I don't know what I was thinking is like on the climate side, for example, like many times, like the project will like show some kind of scenarios for the global scale or something, but then every study that are actually looking at adaptation are usually is always like on specific region or very local scale, which also means that actually like the interaction between like the climate modeler, like myself, and like the people that will actually use our scenario don't exist much, and actually it's like one of the things that needs to be improved in the future to actually like develop this kind of solidarity. It's like we need to actually work directly with the practitioner and end users to produce something they can use, and also we need to have probably some kind of program on adaptation strategies that are not focused on specific area, but also like address like global challenges to actually include everyone in a global challenge and in a global question, instead of working specifically with these people and these people in this part of the world. That's yeah, I think that's what I would have answered to this.
Thank you, thanks. Bastien, and both of you. Chiara, you had a question on informal actors, presumably for Gareth?
Yes, that's a question for Gareth. So thanks a lot for your presentation, and I felt very close to your work, even if you work in different geographical contexts, as I'm working around building an agroecological urbanism. So I was wondering, when you mentioned that the informal economy is a crucial place for struggle. So I was wondering if in your experience in the context in South Africa, you are finding particular strategies that they are putting in place to, let's say, stop and revert urbanization dynamics, which we know that they are constantly eroding livelihood, constantly eating land and making people's life precarious. So maybe some of these are, learned from the agroecology experience, or maybe they are just based on local creativity and solidarity in context. Thank you.
Yeah, I mean, for me, there's a couple of entry points to that. One is really seeing the sort of informal economy movement around the world. And I work closely with WeGo and how they're trying to really think around solidarity from waste pickers to a whole set. And I think play a critical role in not just, the reversing land-based issues, but kind of absorbing and recycling wastes and a whole set of those actions and how they function and the deeply gendered notion of that. I think for me, on another layer, I think the sort of informal vendors offer significant resilience because the poor have multiple options. They can go and get credit from somewhere, they can buy smaller packs, there's bulk breaking. So there's ways in which resilience and sort of hacking the system, for want of a better way, is playing out at various different scales. I think at a broader scale, and sort of to your question as I understood it, what I'm increasingly interested in is how sort of traditional notions of urban management, such as design and urban planning, when they adopt a food lens, can they play a different role? And there's a really interesting tension, and I used food sensitive planning as one of the northern concepts coming from Australia in this instance, but how it sort of sees this way to plan and sort of embed food in the planning. But the informal economy is, the idea of planning is to design and sort of structure something and then eventually occupy. What the informal economy is doing is occupying and then trying to embed design and planning and legitimization as it evolves. And I think there's some very interesting ways for us in the South to start to think of how we can embed a sort of food sensitive planning, but how we can do that in a way that sort of takes lessons from the informal economy and how they respond and how they build resilience, and ask some questions. Heidi asked a question in the chat around vendors in this very diverse food system where she lives, and how, what this might mean for local versus others and how food might come into the system. But I do think the informal vendors have these very strong networks that are often broken and often ruptured. But I think when we adopt a food systems plan and start to think of a city through a food lens, it might help retard some of this encroachment into productive agricultural land. It might drive densification. It might drive different ways of cityness, prevent the sprawl, prevent a lot of these challenges that we have. This assumes governance can act, but can society do the same? So I don't have immediate answers. This is work that I think is part of this evolving project of trying to understand this, but I think there are clues and cues within that to start thinking more deeply and very differently about both the food system and cities and the informal economy.
I wonder if I can return with another question related, because you mentioned planning, and so in my understanding, planning and sustainable food planning that's been emerging in the past 10, 15 years tends to, suddenly rediscover food and say, oh yeah, let's plug food back into the city, like if we've never been eating before, But it seems to me that it's usually very, high tech, is very far away from agroecology. They think, oh, well, we got industrial buildings that are not in use anymore, we can use them for food, but it's not really keen in altering, when we go into actually land use or traditional realms of planning, where planning goes closer to economic interests. That's where there is the big wall. So are you positive that we can, with the planning, sustainable planning that we have at the moment, that we can really break and really bring forward a food system that is radically based on agroecology?
The short answer is no. I'm not confident, knowing how planners function and the problematic that you just presented. But I also would like to kind of say, can we think differently? That, for me, the informal economy, that description of them occupying before kind of formalizing, they're planning in a different way completely to the planners are planning. And so who are planning the city? Who are building the city? Who are constructing these African cities that are growing so rapidly over this time? And planning is just unable to catch up in the formal planning registers. So for me, there are clues and there are ways in which planning can do things. In South Africa, we are actively pursuing a process and kind of having some success with fairly senior planners and government institutions to say, before anything is built, there has to be a food system assessment. So if you're going to build a shopping mall, how is that going to impact the informal vendors? How is it going to change? If that shopping mall forecourt is going to have fast food outlets, how is that going to transform the diets in those neighborhoods? And if they are going to have negative outcomes, they cannot be allowed to continue, much like an environmental impact assessment. That's a very normative, very structural governance-based process. But I think there are opportunities for planning to be far more kind of insurgent, far more disruptive, and the work of Vanessa Watson and conflicting rationalities and all of that comes into this, and how these different worldviews need to find a way to connect in different ways. And I think, seeing, and this is why I do, and I'm still in favor of notions of pluralistic governance and trying to create these multiple governance processes, but that needs voice and agency to emerge. And at the moment, the current system denies that. So how do we unlock that, and can agroecology allow that voice and agency to come out, that there is a different form of food democracy and planning democracy in cities, is my question, and a perhaps sort of short answer to that question.
Thank you, Gareth. Thanks, great. That was great. I wanted to hand it back, I think, to Bastien. Eric had a question about comparing models at spatial scales, and I'm wondering if you can speak, Eric, if you can ask that question.
Thank you, Bastien. You did talk about climate impact assessment, and you actually showed a diagram with models at different spatial scales. I was just wondering whether environmental impact assessments, where you have matrices where you can use that to assess the impacts of different activities on the environment, would climate impact assessments also have that kind of metrics? Have you, to the model you show, have those kind of matrices inbuilt into that, so that you can actually tell yourself these are the things you are looking at when you are doing climate impact assessments? Thank you.
So when I show like this kind of reverse pyramid from the climate model to impact model, actually I'm not talking about just one model on this. So on like for example, when we talk about global climate model, the IPCC actually have a program that is called CEMIP, in which you compare like many different global climate models from different institutions in the world. So I don't know, probably about 40-50 institutions producing different version of their model and different simulation of their model. So in the last paper I wrote, I was using at the end 350 simulation, and so that's already like a large number of global models to compare. And then when we move to the regional scale of the model, what we do is that we use this global model actually to force to include a bit more variable over a smaller region. So we take the global forcing, we put it in a small region, and we use a new equation to reassess how the climate will be. Most of the time, it's following what the global model was proposing in the first place. But so, which means that we, between the regional or global climate model, we kind of have an equivalent uncertainty. It's quite high in any way, because some model will not be very well performing in some region of the world, and will be in other. Some models are poorly performing in some region of the world, but well performing in others. So when we do an impact assessment, we usually try to take as much model as we can. We first evaluate them to see how good actually they will be. If we can actually, in some good model, fix some bias to have even better or more realistic scenario for the future, and then we send it to different crop model. And even at this stage, actually, many studies will just use one crop model, or if we talk about water resource, we will take one hydrological model. That's actually also another mistake, because if you use another crop model or another hydrological model, that's another uncertainty. So if you want, we got some ways to evaluate the climate model. Based on this evaluation, you can either give some weight to some model, or exclude some model if they were really poor and don't include them in the impact. We still try to have a lot of simulation for the future, to have some kind of a large number of simulations from which we can actually deduce a robust signal actually, and then we send it to optimally to more than one crop model to check if actually another crop model with different equation will also produce something similar. So all the way, usually from the modeling chain, you're evaluating different model, different climate model, excluding the one that isn't working, and to at the end produce a large number of information, and optimally show what would be the most severe, or the least severe scenario, and also what would be the most probable sometimes. That's the way the system currently works. I think it answers pretty much your question.
Does that answer your question, Eric?
Yes, Bastien, thank you very much.
Great.
I need to get my head around that anyway. It's something I'm interested to just understand more. Yeah.
Thanks for that. That's great. And of course, there's more reading in the folder that Bastien and Gareth have both popped in there. So I'm going to pose a question from V, who sadly had to leave us, but she was interested in firstly, Bastien, perhaps you can expand a little bit on understudied phenomena like the Indian Ocean currents. They're called the warm blob off the coast of East Africa. And then Gareth, as the second part of this, perhaps you can connect this to observations of changing weather cycles to the political economy of so-called drought-proofed seed. I'm assuming she's talking about GM seed.
So so I have seen this comment on the chat on the ocean, Indian Ocean warming. Mm-hmm. So it's actually it's not really a problem in terms of prediction, because we actually detect this warming in the different model we use actually for the 21st century. So we're already able to predict this. What's actually a bit concerning is like this warming over the Indian Ocean is sometimes a bit weaker or stronger in different models. It's actually sometimes impact substantially the result of our prediction. But that's also like one way we can evaluate and select the model or exclude the models that are least performing, by just like checking if actually that's one of the parameters we can check to see if the model are able to produce this or not, to see if there will be at least show some realism for the coming decades. The reason it's actually important is in my presentation I talked a lot of time about seasonal quite a long time for the seasonal forecasting based on so based on what's happening in the Pacific Ocean. Actually, what's like the relationship between the Pacific Ocean and the precipitation everywhere in the world on temperature also depend on what's happening in the Indian Ocean. So if the Indian Ocean is actually warming more than we expect, it's going to change the relationship between ENSO and the rest of the world, which means that the system we currently use for the seasonal forecast or multi-year forecast will have to be changed as well. But to change it, we will have to include actually information about the Indian Ocean in this system.
Thanks, Bastien. And Gareth, can you speak a little bit to the political economy of seed and the responses to changing climate?
I mean, thanks. I'm sure it might come up later, and I'll give my view on this. And this is largely informed by that history that I presented, but also having seen crops that I know are far more drought resistant growing in South Africa as a young child, and seeing non-cultivated crops, which are today called weeds, and having harvested them myself. So I find this notion of producing drought resistant crops really kind of problematic, when many of these crops have already existed in Africa in the forms of the millets and the sorghums and the wide variety of crops that are here already. And so how this speaks to the sort of changing diet and this obsession with staples and this transition to a sort of maize monoculture, it's kind of created this problem now with climate change, and now they're trying to sort of engineer a response to that rather than kind of really kind of celebrating these crops. And this was what was so interesting in India, and how the sort of symbiotic relationships, the intercropping, and related to a question, and how the sort of benefits of this sort of diversifying the food system came about, not just focusing again on trying to engineer single crops that will provide staples. I think for me, going to the political economy, we've been, since Elric and Elric's book, The Population Bomb, way back, and the sort of this obsession with hybrids and then later seeds, it's always been trying to feed the world. And I think the world produces enough food. I think it's how do we rethink the systems? But in the context of climate and climate variability, and to kind of drill into a question, I think there's another layer to it, because I think what I've found is that particularly the poor and the food insecure have increased vulnerability already as a result of climate variability. Intense shocks as a result of flooding, as a result of fires, intense heat, a high other levels of sort of disease spreading, and all these issues, and kind of the nature and the health of cities is already being impacted significantly. And these all impact on the kind of affordability and the money that's left over for communities to actually spend on food. So there is this race to sort of buy the cheapest food to reduce dietary diversity. And I think this presents a real challenge, and again, increases the urgency and the need to try and find alternatives and to respond to this. And I think for me, this notion of obsessing about sort of these crops that can be drought resistant, there might be some changes, but I think for me, what I learned from my work in agroecology and how I've seen both producers and others responding to these is how they can start to really change how the food system is structured, rather than trying to think about how we can have, and again, it goes back to the smart city notion of this technological fetishism that I think pervades so much and is able to be adapted and sort of absorbed by governance actors so easily. I think there is this need, and kind of how does this get enacted is the question that I grapple with and try to understand. So yeah, I'm warbling a little bit, but I think that hopefully that answers some of that question, sort of yeah, in some way.
Thank you, Gareth. We've got just under 10 minutes left, and we've got 2 more questions. I'm just trying to keep track of them in the chat. But we've had an interesting discussion kind of emerging around land access and tenure, and I think perhaps kicked off by V's comments about enclosures and the colonial expansion of enclosures. And that's kind of a conversation that's been happening between Heidi, John, Adam, and potentially others. So I'd really like to open that up a little bit and have you speak to that. But I think one last question, if I may. I think you had one, Chloe. You had another one. You've already asked one, but it's an interesting question. Do you want to ask that question?
Sure. Yeah, I was just trying to, like, the talks were both really interesting, but they felt quite disparate. So I was trying to think of what the kind of connection between them was. And it seemed that, you know, Bastien was talking about the need for production practices to change, essentially to adapt to climate change. And then Gareth was talking about the sort of different players in the food system, but particularly the informal food vendors who can maybe disrupt the sort of bigger, more industrial system. And so then I was thinking about, can those informal food vendors also support those adaptive production practices? Or are they the very people who want really cheap mass-produced grains in order to be able to on-sell them? And so do they, if you follow the market, that might happen. Do they need to sort of have some extra action or motivation in order to support more diverse, more adaptive practices?
Gareth, do you want to speak to that one? Yeah.
Yeah, so Chloe, I mean, for me, my work in Epworth, so not in South Africa, just outside Harare, was fascinating because there was this direct connection, and I perhaps did it in a somewhat gormless way, showing the maize producers, and you know, whether that was hybrid or not. I think what I've seen in Kenya, and Paul is on the line, can speak to the millets and the sorghum that are milled at the posho mills that get into there. These informal economy actors certainly have the potential to drive that. And there is still a desire for those foods to go into the system. I think the challenge is when that food needs high levels of processing, when that food needs lots of energy to cook and things like that, and it's not easy to release the nutrients of that food and provide the satiation because of other faults such as infrastructure and others. That's when the adaptation and the kind of ability for them to be absorbed is inhibited. And so I think for me, this is where sort of a wider food system discussion, as I kind of try to think of the infrastructure systems and these other systems that also need to be in place to effectively unlock those opportunities. But just to mention, even now across Cape Town, it's fascinating to see how, you know, informal vendors are actually going themselves and purchasing directly from farmers and even getting them to produce covos and rape and okras and things like that that are not grown by the industrial farmers and the commercial farmers. They're finding other farmers who are able to do this. So they are making these inputs and these alterations, and they are disrupting the systems, but within a limited scale. And for me, given the climate kind of crisis that Bastien presented, this needs to sort of be accelerated in ways and sort of capacitated in very different ways.
Thank you. In the 5 minutes left, it's a hell of a topic to throw out to the floor. But perhaps Heidi, John and Zira, Adam, Carlo can come in to really explore the issue of land tenure that you were discussing, land reform, agrarian change, essentially. Does somebody want to come in with that one?
Well, I'll give it a shot. I mean,
Sure.
I think the first thing is, oh, why don't you go, John? Yeah, that's fine.
Oh, okay. Basically, I was trying to understand how do we deal with this issue where agroecology is an investment. When we are implementing the agroecology systems, it's really an investment, but we have a big question that most of the farmers or smallholder farmers, they don't own the land. And sometimes the land is in the hands of the government, or it's in the hands of the minority. And how can we deal with that so that we have justice on implementation of agroecology or climate change adaptation programs? Thank you.
So yeah, it is such a significant issue, and sorry, I did deliberately skirt around it, and it's perhaps sort of the luxury of being in the urban space. But John, and good to see you again. It's been a long time. For me, food system change cannot happen with changes in tenure and without a fundamental disruption in the tenure relationship. As I feel, and equally I feel that even when there is land reform, there has to be a fundamental change that takes place within the food retail environment as well to disrupt that sort of that lock-in. How that takes place, I mean, for me, and I agree, you know, just trying to sort of generate and build the soils and seeing those farmers that I walked around with in India, they'd spend 10 years sitting there building that soil, speaking to permaculturalists, you know, biodynamic farmers here in the Western Cape, this deep connection to the land and the observation of those fundamental changes that happen, fundamentally change how they view both the land and what is happening in the soil. And that takes time. And as you rightly say, you need tenure to be able to enact that. And so for me, it's an essential component. I don't have the answers. I wish I did, but I don't have the answers to that. But for me, a discussion about climate change and adaptation and how we can respond to that cannot take place without really fundamentally shifting the kind of structuring of the sort of agrarian economy and how land is owned and ownership across that. So yeah, it's a short answer, and I'm sorry, I know I don't mean to disrespect the depth and the importance of the question. Yeah, it's perhaps the best answer I can give right now.
And I'm going to throw that back to the floor because I think, I mean, the whole part of this, the whole kind of reason for this process is that we're all learning from each other. So I know Adam has also been working on land tenure issues in a different context. And I know Heidi has written about this as well. So would you like to would you like to speak to John's question, Adam or Heidi?
Well, I just tried to link it to the first presentation. I think there's a problem and an opportunity with the use of climate modeling and land tenure, because what you do is you get these little pixels that demonstrate, you know, high opportunity for adaptation or high potential for carbon storage, but the modeling doesn't necessarily understand who has control over that land underneath those pixels, and there's a real risk for the efforts, the benefits of policy to try and, you know, mitigate or adapt to climate change to go to, you know, this is an old story, but to elite capture, where it's really those with secure tenure that can move fast and change their land use model to meet the demands of the climate modeling. But at the same time, I think there's an opportunity there to suggest that if you're going to try and make large-scale changes based on modeled predictions of vulnerability, then there has to also be a land tenure design that goes along with those demands and land use change. And I think that should be a point that should be contested every time there's a kind of spatial determination of where needs to be changed. So to add to the land tenure piece there.
Thanks, Adam. I think that's really important. And I like the idea of what's below the pixels. And
I
I don't know.
can answer a bit about this.
Yeah.
Yeah, so they, like in the different scenario we produce, so you've got scenarios that are like at the where like on pixels that are technically usually based on precipitation and temperature, which many times don't really account on what how like the land use, like how the land use is gonna change. But yeah, for example, in my work in specifically, I work more on water resources. So what we do also in this is like with the agroecological model, you also produce different kind of land use scenario. And I think what's important to understand also about like the use of this climate information is that they are not really here to tell you what needs to be done or what's the change. It's to be here to actually try to test some hypothesis of adaptation and what test some probably if in the next 30, 40 years what strategy could actually be more resilient or least vulnerable to climate, to be used in this way and not in a literal way where like in this pixel you need to change this. That's not how they should be used.
Thanks, Bastien. Thank you both for those great presentations, and thank you for all of these great questions as well. We'll be, in the interest of time, I think we'll close for now, but we will be sending around the recording of the session, so you can watch it again at your leisure. Nina, do you want to wrap up?
Thanks, George. I don't really have much more to say. Just, you know, thank you so much for being here. Thank you for joining us. Please come and join us next week. For those of you who are not part of the wider project, everybody else, we expect you to be here. And yeah, we hope to continue those conversations, both, you know, offline in email and as well in these sessions. I think that's all. I'm going to save the chat, or George, are you going to do that as well? Because there was quite a lot of, you know, interesting links and so forth in there. And so we'll make the recording as well as some of the links available.
Yeah, absolutely.
All right.
Thanks, everybody, and see you next week. Same time, same place.
That's right.
Everyone, thank you.
Bye-bye, everyone.
Bye.
Thank
Thank
you.
you.
Bye.
Thank you.
Thank you. Bye-bye.
Thank you.
Bye.
Bye.
Bye-bye.
Bye-bye. Thanks for coming.
Bye.
Bye.